Vanya.
Hello. Hi,
Good to
everyone.
see you.
Good to see you too.
Yeah, long time no see sort of situation.
Yes.
Good to be on the other side being a host and having you as a speaker. So
Yes. I remember being on the other side when you were one of the panels on the webinar.
that's right. That's right.
Excellent.
So
Good to
wishing
switch
people
places.
are absolutely. It's good to be playing different roles.
Yes.
All right. Thank you so much, everyone, for joining today. Welcome, everyone. I hope things are all well with you all from different parts of the world. So thank you for so much for joining us today. Today's guest is Vanya Seth. Vanya is a strategic consultant specializing in platforms, delivery infrastructure, evolutionary architecture, and cloud native applications. Vanya is currently she's playing head of technology for Thoughtworks India. Vanya shapes new pursuits, strategically advises on client projects, formulates meaningful and resilient technology strategies. She's a passionate technologist, and I've seen her don multiple hats of Thoughtworks, being a technologist, be an open source person, being a facilitator of multiple boot camps, being a host for events, multiple things that she has done. I don't know if there is any other things that she had not tried yet. I've also heard she's a certified yoga teacher. Maybe that's the secret sauce of Vanya to keep her energetic in playing all these roles. So Vanya, it's a pleasure having you on the Voices of Community February edition. How are you today?
I am absolutely fine, Manoj, and I am equally excited to be here. And I'm looking forward to sharing my knowledge and my experiences with all the amazing listeners who are joining in us from different parts of the world. So yes, wishing everyone a good morning, good afternoon, or good evening based on wherever you are joining us from. And I am Vanya. I think already Manoj introduced me. I'm playing the role of head of tech for Thoughtworks India. And in this talk today about observability and testing in production, I would lay down some of the practical experiences that I have made in my experience of 14 plus years. And hopefully some of this would be useful for you, and you can take away something meaningful for your daily work and daily business. So without any further ado, let's get into it. And the landscape today, right? Even before I start to describe the majority of the landscape today, let's take a look at some of the historical perspective. And I should not rather call it historical, but more of what was prevalent in the, say, a decade ago, or in some cases, it might still be prevalent, today as well in the current landscape. And that's where, goes a story of one of my experiences, say about 8 years ago. We were working with a monolithic application, and it was a single deployable unit. So I think a lot of you would remember the WAR files or the web application archives that we used to deploy on web servers or app servers like a Tomcat or a JBoss. So that's the era that I'm talking about. So it was a single deployable application which used to get deployed on a Tomcat instance in, say, a VM, right? And at that point of time, we are talking about a single runtime, since it was a Java-based application. So it was a single JVM that was running. And at any point of time, right, by monitoring some of the signals of my application, I could derive whether my system was up or down, right? So it was a very binary sort of a situation, right? Whether the system was up because my web application was responding, or it was down because the web application was not responding, right? So basically, the point is that we were deterministically able to answer whether the system is able to respond to the end user queries, and whether it's and how it's impacting the business, right? So that was a very deterministic thing. And at that point of time, because it was a simplistic application, a monolithic application, and all the interactions were happening within the process, it was a single process that we were monitoring. So simple monitoring was put in place, right? So I still remember, because we were working with a humanitarian organization, and the budgets and all in such cases are very low. So we had to use a lot of open source tooling, right? So there was this interesting monitoring tool called Monit, which we were using for the monitoring of this application, and simple metrics like the CPU usage, the uptime, the downtime, and memory used, since it was a Java application, the heap and a lot of aligned metrics were being measured or being monitored. And at any point of time, it was very simple to know what's the health of my system, right? So that's like a predated view of how monitoring in such a simplistic scenario where it was a single process actually worked, right? And it was not a very complex sort of a setup, right? We could grab the log files, we could SSH into the instance that we had procured, although it was hosted by some third-party service, but it was more of a infrastructure as a service, right? It was pretty popular about 10 years ago, right? So it was an instance with an IP address that we had gotten, and we could SSH into the box. We could look at the web server logs. We could grab the log files. We could figure out what was happening. So basically, the basic setup was in place, right, for us to be able to gather some of the basic telemetry data on the metrics and say what's happening with the system, right? But as we moved, towards a more complex environment, which includes microservices, right? Dozens and dozens of microservices, right? We gained the autonomy of deploying different parts of the system. We gained the ability to evolve different parts of the system at will, right? We created autonomous teams. But then in this entire process, we accrued, attacks, right? The tax that we pay when we actually start to build distributed systems, right? So now from a single deployable unit, we came down to multiple dozens of microservices, heterogeneous microservices built with different tech stacks, polyglot microservices, right? Depending upon the use case or the business problem that we were trying to solve. That whole system emerged as a set of interdependent services, right? Fulfilling one thing or several business capabilities that were relevant for a given bounded context, right? And within that realm itself, the idea of cattle versus pets can also be understood, because the first example that I took, where we were working with a monolithic system, the instance that we had gotten was more like a pet, right? We knew the IP address, we could get inside the box, open its gut and figure out what's happening. But with more and more uptake of the cloud in the last decade or so, I think with more and more serverless getting popularized with the help of managed cloud services, I think the infrastructure is now more of a cattle-based stuff, right? Where we are not really worried about it's ephemeral in nature. It can spin up and die down at free will. And it's more in a cattle mode rather than a pet mode, right? So that's again a difference. And that's where another example that we should look at when I say that there are exponential possible states in a microservices ecosystem with dozens of microservices, coming together to sort of fulfill a business process. So if we take an example of a e-commerce application or an e-commerce setup, if we look at the order to cash process, right? In the order to cash process, if there are multiple teams, right? There are multiple teams who are looking at different parts of the business process. So if you look at it, there is a team that manages orders, right? There is a team that manages billing or the pricing. There is a team that manages returns. There's a team that manages payments. So all of these are independent autonomous teams who are part of this entire business process of ordering something from the web shop right to the payments and actually the delivery and the returns part as well, right? Each of them are independent teams. And each of these teams are hosting their own microservices to fulfill some part of the business functionality that are part of this process that we just talked about, right? Now, you can imagine that in this entire business process, there are so many touch points, right? Like one simple business process is making a lot of hops across all of these services, right? And in such a scenario, as a team, I know what's the equation within my boundary, but I do not know what is the place or what is the point in time in which my business process is from the perspective of the user at any point of time, right? It could be possible that we are not able to create the proper invoice at the billing step. It could be probable that we are not able to actually charge the credit card of the customer in the payment step. It's also possible that we are not able to capture the right products in the order management step. There are a variety of exponential possible states that our system as a whole can be for this entire process, right? So that's the idea of in a microservices ecosystem. When I have multiple services fulfilling a large business process, my system could be in exponential possible states, right? And that's where, from a quality engineering perspective, I would say that you cannot test it all. You just can't test the entire landscape or all the possible permutations and combinations in which the system can be at any point of time, right? Because anything can go wrong, right? And I think that's the most important thing to understand, that the complexity of the landscape that we are in today in the microservices world, anything could go wrong, from the network to a business functionality to a database connection. It could be just about anything in the entire ecosystem of services, right? And when we talk about anything could go wrong, what we are talking about is that there are a lot of unknown possibilities that lie ahead for us to understand, right? And that's where I want to move to, a very interesting framework. I'm sure a lot of you have already heard about it, the unknowns and the knowns framework, right? So if we plot the unknown and the known on a 2x2 matrix, we would look at the 4 quadrants. We have known unknowns and unknown unknowns, right? Like, let's look at these two for the brevity of this talk. In the known unknown, we are talking about the things that we know, but we don't fully understand. And in the unknown quadrant, which is the top left, we are talking about the things that we don't know, nor do we understand them, right? Now, if we map this framework to how we look at observability and monitoring, right, let's take an example again, right? Now, I'm sure a lot of you must be using AWS or any other cloud for deploying your services, your workloads. Now, if you are using, say, an AWS EC2 Elastic Compute Service from AWS, there are a lot of out-of-the-box metrics that are provided, right? Like CPU utilization, disk IOD, disk IO bytes, and disk output, and network, and many, many other metrics that are measured, right? Now, we know that when we are designing any software system, the CPU utilization of that machine on which we are going to deploy our workload is an important factor, or it's an important part of the system that impacts the performance of the application, right? CPU utilization. Now, since this is a known thing, what do we do generally? We put up an alarm, or we put up a metric and CPU utilization, and we put up an alarm on top of it, right? We would like to monitor it, that as my application is used in variety of loads at variety of times, whether it's the peak hours, whether it's the normal hours, or during Black Fridays or things like that, I am looking at my CPU utilization for all my EC2 instances, right? So this is a point that I am aware of. I know that this is important, and hence I'm going to monitor it, right? I'm thinking this is a very simple statement to make. Everybody would understand it. But what's the challenge here is that in certain peak scenarios, sometimes the application works just fine, but sometimes the application is incredibly slow, right? So my CPU utilization as a metric, when I'm monitoring it, even though it's telling me that everything is okay, the CPU utilization is probably under control, or CPU utilization probably has crossed a threshold, but in some cases, the application seems to work just fine. And in some cases, the application seems to be extremely slow in responding, right? Now, what we are not understanding is why it's behaving sporadically in certain situations, right? And that's where I think we should understand the difference between monitoring and observability, that monitoring allows us to look at the failure symptoms that we already know, right? Or the challenges or the known aspects of the system that we already know when we are designing the software system, right? We know that CPU utilization is an important metric, so we monitor it. But when CPU utilization is very high and still the system is working fine, and sometimes it's breaking, that is something that we do not understand just by looking at that monitor, right? Just by looking at that dashboard. And that's where observability comes to, shine, because that's the place which is going to tell us why something is behaving the way it is behaving, right? Now, there is another example I would like to give here, again, from my experience in the past. We were deploying our applications and workload, again, in AWS EC2 instances. And there were a couple of other processes also that were running along with the JVM, which was the the deployed application that was working on AWS EC2. What was happening is, again and again, since it was a Linux-based instance, the out-of-memory killer. So Linux systems have this interesting out of memory killer process that which rises from nowhere if the system memory is going beyond a point, and it kills any process in random order, right? And what was happening was we were monitoring the memory. Like, so since it was a Java-based application, there was JMap that we were using to sort of look at what was the per JVM, heap dump, or per JVM memory consumption. So we were having all of those agents and processes running besides the main service that was also running. But again and again, our application process was being killed, right? The Tomcat server that was running on AWS EC2 was being killed. And it was quite inexplicable, right? So what helped us? What helped us here is observability of the system, right? We could look at what were the sort of application logs, what were the sort of traces, and what were the sort of other information that was being present in my logs on what was happening with that process at that point of time, right? And that's where we realized that it's the out of memory killer that rises up because the overall system performance or system memory was being exceeded, and it used to kill our application process, even though the application process in itself was not crossing the memory threshold. So now you see that even though we were measuring the memory threshold of my main process, still the system was killing it because of the overall setup of the box in which there were other processes running, right? Now, imagine this situation, right? I could monitor my processes memory, but only with the help of observability could I answer that it's not the problem of my application, it's the problem of how the other processes are and what's the memory capacity that I'm using for my particular instance. And it was a simple fix that we increased the instance from, say, a smaller memory footprint to a higher memory footprint, such that the application process used to survive, because now the OM killer was not, killing our process, right? So you understand here, right, that what's the difference between monitoring and observability? And that's where I would like to very simply call out that observability is not monitoring, right? I have seen in my experience a lot of teams conflating this term, that, and they use it interchangeably, observability or monitoring or observability, and it just makes me cringe, because these are two different things, right? There is a relationship between them, but these are entirely two different things. And whenever I hear them in the same sentence as if they mean the same thing, it just makes me feel that maybe people do not really understand what are the differences in between these two terms, and how do they relate to the software ecosystem as a whole, right? And that is where, in order to understand this, let's take a look at a very simple situation, right? Imagine there is a profile API in your ecosystem, and the metric that we are measuring is, say, latency, right? What is the latency of my request as they wait for the API to respond, right? And I'm measuring my metric latency over a period of time, right? So the axis that you see from which the arrows drop is the axis of time. Now, with time, I see that the latency of my API is increasing, right? You see this up arrow on my screen, that the latency of this API is increasing. And at about some point of time, my alarm goes off because my latency has crossed the threshold for my 95th percentile, right? That means I have set some particular threshold for what should be the latency for my API to respond. And I want 95% of my requests to fall in that threshold. And as soon as I hit that threshold, an alarm goes off, right? Now, at that point of time, the dashboard is telling me that the latency is going up, but it's not telling me why is it going up, right? So what am I going to do? What is the natural thing that comes to my mind? I should probably look at my system logs. I should look at what are the kind of traces at that point of time? What are the kind of user requests that are coming at that point of time? And how are they going through the system? I would want to look at some of the metric values just at that point, right? Within that trace or within that span, I would love to understand what are some of the metric values for my API, right? And I will do an investigation on why is the latency increasing, right? And probably based on that investigation, I'm going to put in a fix, or I might just add a new alarm or add a new metric based on my investigation, right? Because it's probable that my profile API's latency is increasing because of the load balancer timeout, because the load balancer is not able to reach the backend APIs. It could be just about anything, right, in this entire microservices sort of an ecosystem, right? So just keep the situation in mind. We're going to revisit it in some time, but you do understand that here monitoring allowed me to look at the latency as a metric is going up. Yes, fair enough. But it was not enough for me to understand why that metric latency was going up, right? For that, I had to deep dive and understand what was the data that my system was exposing to me from an internal state perspective to make any investigation possible on top of that, right? And that is where let's try to answer, as I said earlier as well, what is observability? And that's where I would like to put down a very simple definition. Observability for me is about from what is not working to why something is not working, right? So from what to why transition is what observability is about, right? And if you look at this graph or this, again, this known and unknown system or the matrix that we discussed earlier, the black circle that you see or the black oval shape that you see here is the observability spectrum, right? Or the observability area that we have, right? And it's like, think of this like a game of unlimited possibilities, right? The more we understand, the more ground we cover, right? But the monitoring is just the white part or the white circle that you see. And the arrows here denote that the more we understand our system, the more ground we cover. And similarly, the more we understand the system, we understand more of its known failure symptoms such that we can monitor them, right? So they are both pushing out from where they are and evolving in their own directions, right? And therefore, it's very fair to say that observability is a measure of how well can I infer the internal state of the system using only its outputs, right? Outputs that the system itself is emitting out in the world, right? And again, from a quality engineering perspective, right, as a QA, what are the ways in which I am observing my system, right? What are the ways in which I am making down or writing some hypotheses on how my system is behaving and in production, right? In fact, a lot of awesome QAs that I have worked with in the past, they had a very interesting way of working. It was not, for them, it was not about the number of bugs that they were opening. For them, it was about understanding and observing the system in production as to how the system is behaving, right? And what are the ways in which they can understand the system better just by observing the outputs that the system was emitting, right? And we will talk about the variety of those outputs in a while, but that's what the role of QAs was in such an ecosystem, right? In a complex microservices ecosystem where it's extremely hard to write and cover the test cases for almost all the possible states, my system as a whole, could be in. And therefore, some sort of on a lighter note, how much quality is enough or how much testing is enough, right? I mean, I'm sure a lot of you from the QA community must have seen this joke that a software engineer or a software QA engineer walks into a bar and orders 0 beers, order a single beer, orders out of the floating point number beer, orders a lizard, orders -1 and whatnot. But when the first real customer walks in and they ask for a bathroom, the entire bar bursts into flames. So I think the point here is that the way the users are going to use the system is extremely unpredictable. It's unknown, right? And therefore, as a quality engineer, it's almost impossible for me to map down all the possible scenarios and to test them out, whether in the form of integration test or system test or journey test or boundary test or whatever kind of test that we love to write, right? It's just impossible to cover all of those scenarios in the form of testing to preempt errors from happening or things to go wrong in production systems, right? Like the Dilbert, I love Dilbert, full disclosure. So this strip just sort of resonated really well to depict the scenario and how much quality do you have and how much of that quality is enough. We have plenty of quality, don't you worry about it. So I think that's the beauty of it, right? Like how much is enough? I think it's a very hard question to answer, specifically in the microservices ecosystem, because as a quality engineer in such a complex ecosystem, we can only undertake a best effort approach to cover the edge cases. We cannot guarantee 100% of the time that we will be able to cover all the edge cases that are possible in our system, right? And that's where let's take a revisit to the situation that we covered earlier, right? As I was mentioning, the latency is a metric that is a known symptom that we should all monitor, from From a monitoring perspective, yes, monitor the known symptoms, but as soon as the alarm goes off, you need to step in. You need to understand from your logs, from your traces, from your metric values at that point of time, what's actually happening and what's actually going on in the system, right? You are looking at the response time from, say, your load balancer to your backend, or from your client to your load balancer, and all of those aspects you are trying to observe by going inside the logs and the traces to investigate why is the latency actually increasing, right? And based on this investigation, probably you are going to identify new signals, right? So that's the expanding part, right? So if you remember the previous slides that I showed, the monitoring space is ever expanding. And similarly, the observability space is also expanding. I'm sorry. So as we explore more, as we understand our system more, we are bound to cover new signals. We are bound to identify new signals. And the beauty of this entire feedback loop is that we discard noise, we discard signals that are no longer necessary, and we identify new signals and we start to monitor them, right? So that's the entire interdependency or interrelationship between observability and monitoring. So if you look at the pillars of observability, right, there are 3 pillars of observability: metrics, traces, and logs. Metrics are the key pointers that define the health of your system, right? You can set up monitoring for these metrics. Traces are how do you map the user journey through your system, right? As I said earlier, a system today, I think I should take a quick sip of water. So, as I said earlier, traces today are nothing but a map of user journey through the various systems. In the first example of the order to cash process in an e-commerce setup, we said that a service, there are multiple services that are responding to a business process, right? From order management, billing, pricing, payments, returns. There are so many systems, there are so many microservices that are responding to one simple business process. And the ability to map through the user journey, to map through all the service hops that we're making across our system, is the ability to trace a system, right? And tracing is associated with the auditability of the system. How can I audit my business process, right? And last but not the least, it's the logs, right? The actual logs that my system is emitting based on the important events that are occurring inside my system, right? I hope a lot of you would remember when we used to write unstructured logs in the entering this log.debug, entering the method log.debug, some important business calculation, and log.debug, exiting the method, just for fun, right? I hope you remember that. But I think at this time, logs are a lot more. I'm so sorry about my.
No worries, Vanya.
Yeah. So logs could be at different levels. Logs could be at error level. Logs could be at debug level, at info level, and depending upon my system as a software designer, as a system designer, I would take a decision on what's the level at which I would love to log at different types of information that I would love to log, right? So these are the 3 pillars of observability. And this brings us to the very important question on what is your observability strategy, right? I think some of the themes that should come to our mind when we think about observability strategy are we able to do post-mortem of our production issues? Are we able to do root cause analysis and debug if there are production issues in my system? How is my software robustness looking at any point of time, right? And how am I designing my system for debuggability, right? And most importantly, how is observability a first-class concern in my software development lifecycle or in the various cross-functional requirements that I'm looking at, right? So these are the various themes that should probably come to our mind when we are thinking about our observability strategy, right? And in this in this next section, I would love to take you through what are some of these important tenets that are relevant when we are thinking about our observability strategy, right? And I think as a quality engineer, it's extremely relevant and important to look at the entire path to production, right? Because it includes how am I delivering software, how am I writing software, and in that process, it's also about how are my stories being groomed, right? How are the acceptance criteria on my story being identified, and what role is a quality engineer playing in this entire process, right? Right from kickoffs for the stories to the desk check that are happening for a story, and how are the QAs evangelizing observability as a first-class concern across the software value chain of development and also in production, right? So the entire value chain of writing software and putting software in production, observability, how is that a key tenet across all of these phases? And that's where I believe that a QA plays a very, very important role in evangelizing observability as a first-class concern across these segments. And that's where the first, aspect of observability strategy is designing your telemetry data right? I think it's important to know that in the earlier systems, right, when we were working with monolithic systems where we were working with a single process, human readable logs was okay because the humans were looking at the logs. It's not that the humans are not looking at the logs today, but mostly it was system administrators looking into the log files, SSHing into the systems, right? But now I think with more and more serverless and managed services from a cloud perspective, the idea is to be able to deliver machine readable logs, right? So that switch from human readable logs to machine readable logs needs to happen. And that's where it's relevant. Based on the 3 pillars of observability of logs, metrics, and traces, how do we define the right structure of our telemetry data becomes extremely critical, right? Although these things that you see on your screen from designing your telemetry data right seem very simple, but I can assure you many product teams or teams that are building large complex systems comprised of multiple microservices are not thinking about these very simple things, right? Naming convention, something as simple as a naming convention. Think about it, right? When we are writing code, we prefer to use either a snake case or a camel case for our variables, right? Now imagine not having that sort of consistency in your entire code, right? It's going to make your code non-readable, right? It's going to add a lot of friction to onboard any new developer. Now, why does that not apply to observability data? It does, right? The way you design your telemetry data, the way you design the naming convention of your telemetry data for the metrics, traces, logs, it's equally important, right? So something as simple as I will make sure that all my attributes in my telemetry data are camel case, right? Now that's a standardization that I'm putting in place. It's a very simple thing, but largely ignored, right? Second thing is standardized attributes for my telemetry, right? A lot of times I have seen teams represent the same tenet, right? The example here that you see on your screen is product ID. Some teams are going to write that attribute as product-ID. Some are going to write that as prod-ID, and some are going to write that as pro-ID. Now you can imagine that if I am somebody who's looking at the entire business process and looking at the traces or logs across the value chain of different services, it's so hard for me to not being able to realize that are they talking about the same entity? Are they talking about the same attribute, right? So something as simple as how do you standardize on your naming conventions and how do you standardize on the global correlation identifiers that every team should standardize in representing, right? I'm sure in any large system, so for example, in the e-commerce system that I was talking about earlier, there are customers, there are products, there are product schools, there are so many other different types of important entities. And is there a standard way in which I can represent these important entities, right? And that's going to be critical so that my metrics, my traces, my logs, they are more structured, they are more readable for when I'm trying to sort of debug an issue, right? And that's where I think, as I said, structured data becomes extremely critical. And a very popular format is a JSON format, right? I think a lot of you must already be using JSON as a standard way to create a key value pair of what are the attributes that you want to log, right? And as I said earlier, the idea is to have more and more machine readable logs, because the way we are progressing towards leverage of AI and ML in our debuggability and observability. I think in the future, probably a lot of this work would be done by leveraging AI, and it's not very far in the future. I think a lot of systems already in place which leverage AI and ML to evaluate the machine readable logs to give out insights on what could possibly be going wrong, right? And that's where I would say one of the good practices while designing your telemetry data is using open standards like OpenTelemetry. So OpenTelemetry is a very pronounced and stable standard now. I think Open Tracing and Open Census were the predecessors of it. Open Tracing has sort of stopped its setup, and now it's OpenTelemetry, and all the popular distributed tracing systems like Jaeger and APM, they support and are compatible with OpenTelemetry, right? So I think these standards allow us to gather our telemetry data agnostic of the tooling that we would want to use in this future or that we are using in the ecosystem, right? So it's very important to design your telemetry data with these open standards, use these open SDKs to generate that data, that telemetry data, such that we can send it to any type of backend. We can send it to any type of destination where it can be used in a variety of purposes for a variety of types of personas, right? Then about masking of PII data, right? A lot of times people believe that their logs or their traces are very internal information, but and therefore they let PII data like names, emails, email addresses, or any other information be directly available in clear text in their logs. And I think that's a very gross, strong anti-pattern. I think therefore, when we are designing the telemetry, thinking about what are the PII information that I am covering and what is that information that's going into my logs or my traces, it's very important that I create setups while I collect this data to mask that data, right? And last but not the least, from a telemetry data perspective, how am I able to correlate events and metadata between services, right? As I'm making a lot of service hops and I'm doing distributed tracing, how am I able to pass on the relevant context from one service to the other, right? So we should understand that a trace is something that goes across the services, right? And a span is important set of operations within a trace, right? And that span could be within a service, and there could be multiple spans and child spans within a boundary of a service, right? But then what goes and what gets passed to the next service is what's important, and designing and thinking proactively about what should be the attributes in my span. Should I just blindly dump all the business logic related attributes directly into my span, or should I put some thought to it, right? I think that's a very important question that I would love you folks to think about, right? How do I decide and design my span data? What is the information that I should use in my tracing context that should be passed on to the next service such that relevant information is held and I can relate and correlate one service to the other, right? Like the various hops that my business process is going to make, right? So these are some of the aspects that would be very, very interesting to keep in mind while we are designing our telemetry data. The next aspect in the observability strategy is separation of concern. Now, in the software development parlance as well, I think separation of concerns is a very widely understood principle, right? Right from designing classes or right from designing functions, right? We practice separation of concern to the nth level. Now, the same lens, my invitation to all of you is to apply to your observability data as well, right? Now, there is a data source and there is a data sink, right? At any point of time with observability data, my aim is, as a developer, as a quality engineer, or as a part of a team, a cross-functional team that's developing the system, how can I always reliably observe my system, right? Now, what I mean by reliability, even if my system were to go down, even if my, the instance, or if it's a managed serverless function, if that system were to go down, I should still be able to observe what happened. Why did it happen, right? So reliability comes into picture. Now imagine, in fact, I have seen this anti-pattern in some places where the logs were still in the same environment within the same blast radius of the deployment of my service. So if the service were going down, or say the AWS account in which that service was deployed, the same account, the CloudWatch logs were being held and they were not transported outside of that blast radius. And imagine for any reason, if that account gets compromised, my logs are also gone, right? So separation of concern also is applicable to your observability data. The idea is to decouple your data sources from your data sinks, right? Take out the observability data, the telemetry data that we talked about earlier, outside of the blast radius of your current system and services deployment to an outside location, right? Think about some system like a Splunk or a Sumo Logic or a Datadog, right? These systems provide fantastic integrations to export data or observability telemetry data out of the boundary of your transactional operational system, such that even if something goes wrong with my operational system, my logs are always available. And I'm reliably able to peek into the system and understand what happened and why it happened, right? And that's where, right, it's important to know that there are a lot of interesting things like tooling like 𝐕𝐢𝐝, Zipkin, which allows you to, set up systems to export the data from the context of your application, send it to a collector which is hosted, and then that collector can send it to various types of storage, and from those storage we can connect any sort of backend or any sort of visualization on top of it to make sense of that data for any purpose, right? And it's important to know that the reliability of my telemetry data is important because it's going to define my mean time to recover. I'm sure a lot of you must be aware of the 4 key metrics. And one of the important metrics in those 4 metrics is the MTTR, or the mean time to recover. And that talks about your ability to resolve your production issues or production outages in as little time as possible. Now, what is the way in which you ensure that your mean time to recover is as low as possible? If you have the right observability in place, right? If you have the right telemetry data available and emitted from all parts of your application, whether it's your load balancer, whether it's your main application web server, whether it's your Lambda function, it could be just about anything in your infrastructure ecosystem. But if that data is available for you and you can observe that data, you would be able to manage your mean time to recover very, very well, right? So that's where separation of concerns is very important in an observability ecosystem as well. Now let's take a look at a simple exemplar setup here. There is an API, there is a mobile front end, there is a web front end, and that API is emitting a lot of data in terms of metrics, logs, and traces. And that tracing data for that instance is getting collected into open telemetry pods or collector pods, right, in a Kubernetes sort of a system. And I have attached an 𝐕𝐢𝐝 backend, right, the 𝐕𝐢𝐝 backend, which is there, and that collector is emitting and sending that data to 𝐕𝐢𝐝. And from 𝐕𝐢𝐝, I can use any sort of backend like an Elasticsearch or Cassandra. And these are the 2 things that 𝐕𝐢𝐝 supports at the moment, and there are some other storage types as well. And then I can plug in, say, a Grafana or a Prometheus or a Kibana on top of that Elasticsearch to visualize my data, right? So, but you see this example set up that I am taking out my telemetry data out of the boundary of my service and taking it out and storing it in some other place, right? So I think that's the relevance of this simple example here. Let's take a look at a slightly more complex setup and what are the kind of components that might be there in a Kubernetes sort of an ecosystem, right? So that you have your APIs and you are using Linkerd as a service mesh, and it's running as an agent in each of your pods, with each of your pods in each of your nodes. And it is emitting out important information about your observability, right? About your traces. And that's where the Linkerd dashboard comes into picture. And then there are a lot of business metrics that are being scraped by Prometheus, right? So Prometheus as a system is polling your APIs to get a lot of those important data out. And the pod logs, right? At the end of the day, it's a container. The pod logs are being set out with the help of a daemon set, say, to Elasticsearch, right? I'm transporting all my logs outside of my boundary of the services cluster into Elasticsearch, from where I can plug in a Grafana or a Prometheus to create any visualization, right? So there could be a variety of types of users here. You could have operations and release management teams who want to look at the service metrics. There could be DevOps people, who want to look at the infrastructure metrics or the functional metrics, from a business perspective, right? So there are a variety of users, and that's the beauty of this observability data, right? That we can export it outside, and then visualize it, aggregate it in variety of format to make it available for different types of users. And one of the other aspects of the observability strategy is what to trace, what to log, whether to trace or not to log, or that conundrum. And I think I read this interesting insight. Value of logs is effectively zero until it is not, right? And I think the point we realize that, oh, I do not really understand what happened in the system. That's the feeling, that's the time we realize that if only there was a log, if only there was a trace that was available at this point of time, it could have given us some information about what was actually happening inside that operation, right? But when we think about what to trace and what to log, I think there are a couple of other dimensions that we should definitely look at, right? How do we manage the capacity of our systems that are holding the observability data, right? There are cost implications associated. I think I would say that observability comes at a great cost, right? And I have seen in my practical experience that when a particular team becomes over enthusiastic about logging or tracing, they just blindly dump everything in their traces and in their logs. The volume of the logs just blows out of proportion, right? I have seen the Splunk collector getting overwhelmed because there is a new deployment of a service that has happened and that has actually overwhelmed the collector, right? I've seen this in example. And what used to happen was, because of that, it used to start dropping a lot of logs, right? And because the volume of the log is so heavy, and I think it traces back to the first point that we covered, which is, are you thinking about the design of your telemetry data? Are you thinking about what are the attributes that I should actually put in my event log, right? In my trace, such that I am maintaining the cost from a storage perspective, and also looking at the relevant data that should be present, right? So those are some of the things that you should keep in mind. Then the aspect is that observability is evolutionary in nature, right? It's important to understand that at any point of time, observability is not a static thing. It's not one day that you come and say, now my system is 100% observable and I'm good and I'm going to stop. No, it's not like that. Observability is evolutionary, right? Because we are talking about the unknown unknowns here, right? The possibilities are endless. The more we observe, the more we understand our system, the more we are able to cover the ground, right? So we would have to look at, how do we evolve our monitoring dashboards? How do we cut down the noise on the dashboards? How do we cut down the noise on the alarms that we have set up on top of those monitoring dashboards, right? And how do we improve our logging? How do we improve our traces? How do we log the most optimum information such that we are able to do root cause analysis, such that we are able to do postmortems, and so on and so forth, right? So observability is definitely evolving, and it can never be said to be done, right? And one of my favorites, right, as I was hinting earlier, cost. I have seen observability cost blowing out of proportion because teams do not understand what is the level to which they should log, trace, right? What is the kind of information that they should capture inside it? And that's where it's important to bound the resource usage that you have in your mind for your log, right? And one of the most important bits here is, do you really need to observe 100% of your traffic, right? 100% of your system? And I think a lot of times people do not understand the sampling, right? I'm sure a lot of you might have heard about this, that a lot of these tools in the observability space provide the ability to sample a percentage of your application. For instance, 𝐕𝐢𝐝, which is a very popular open telemetry compatible distributed tracing open source tool, it gives you the ability to create a sampling strategy, right? It gives you the ability to say that I would only sample probabilistically 1% of my traffic, right? So are you a Facebook? Are you a Google? Are you a highly business critical application where you really need to, sample or observe 100% of your traffic? I think there are a lot of dimensions here as well, right? If you say are a bank, right, you are in regulated space, probably it's important for you to observe 100% of your traffic because you are responsible or answerable to your regulatory body on, at any point of time, you should be able to say what happened to a given particular request, right? But a lot of times we are not in such requirements, but still teams end up observing 100% of your traffic, right? I think the beauty of observability is the ability to dial up and dial down my sampling based on the requirement, right? And that's something that we should definitely understand, that if there is a given problem, say for a given scenario, say my traffic from a particular location, people from or users from a particular location are complaining, right? But the other locations are working just fine, then maybe I should just amp up my sampling strategy to sample and observe all the requests that are coming from that particular region and see what's happening there, right? So I dial up my observability for that particular set of requests, right? And as soon as I observe and understand what's happening and I know what are the fixes that I really need to roll out, I can dial down my observability. And that's the way, I'm managing my cost, right? So I'm being proactive about it, and I'm not being, it's because it's not free storage, right? At the end of the day, as a team, it's your cost. You are owning that cost. And if you are not on top of that, it's going to be just biting back you in some point of time, because these stacks are extremely expensive. I'm sure if you have set up Elk stack, you would know that how expensive is Kibana. So a lot of things, like what should be the purge policy of my logs? What should be the sampling strategy for my traces? These are very relevant and important points while I'm thinking about my observability strategy. Some of the anti-patterns, to watch out for, and I will not call out a lot of them. You can read through them. I think they make sense. They are self-explanatory. But the one that I would love to call out is business monitoring with logs, right? That's a very strong anti-pattern. People take their log information and then they try to break down that log information to derive their business metrics, right? That's the strongest anti-pattern that I would like to call out, because that's not the right way to create your business metrics, right? Your business metrics should be derived from your business events, from the important business events that are important for your business process, right? Think about an event-driven architecture, and as soon as an order is created, that's a domain event that your team is emitting. Or as soon as an invoice is created, that's a domain event that your team is emitting. How can we leverage these events instead of the logs, to create the business metrics on top of them, right? So I think the idea is to decouple the transactional system's ability to derive the logs to measure the business outcomes, rather than putting them on the business events that the team emits, is a more appropriate way to do business monitoring, right? And the next one that I would like to call out is open access of logs for all. I'm not saying that in a team we should have any sort of a discrimination on who has access to logs or not, but not everybody in the organization needs access to your logs, right? So there should be authorization, proper authorization on the log data as well, because log data is also data, right? And any data that's there in our systems is subject to confidentiality, integrity, and it's important that we maintain that integrity of the data, because it could be possible that we are logging some customer information which is relevant, and it can be combined to identify a customer, right? So open access to logs is not a good pattern. It's an anti-pattern that one must definitely watch out for. And that's where I come to the most important part of this talk, that how in this ecosystem is the quality engineering changing. And my message to all of you would be, embrace the dynamism of the system, right? It's not about control, as I said earlier. It's not about writing the best integration test or the best testing strategy. It's about redefining your measures of success, right? It's not about opening new bugs and being happy about it. I think now a lot of QAs, they do not even value this metric of how many bugs they have opened. What is more valuable in this entire ecosystem is, how are you redefining your ways of working? And what's an important measure of success for you? Is number of bugs a measure of success for you, or zero bugs and the ability to monitor and ability to observe your system in production a more important measure of success for you, right? I think that's the importance of quality engineering, or that's the way in which quality engineering should be perceived in this complex microservices ecosystem, right? And then last but not the least, I would like to ask you a question. Are you testing in production, right? I love this image from Cindy Sridharan. She, in her blog, has written fantastically about some of these things. And I absolutely concur with her thought process that observability is the all possible permutations of full and partial failure of your application ecosystem, right? Testing is your best effort verification of the correctness of the product that you're building. And monitoring is the predictable failures that we spoke about, number of examples earlier as well, your CPU utilization, your red metrics, request rate, error rate, latency, and so on and so forth, that are important, that can probably go wrong. You're monitoring them, but observability as a whole is this entire ecosystem, right? Where you are testing and observing in production, where you are monitoring, and how all of these things are coming together to allow you to look at what's happening in production and the ability to put out hypotheses and then put them to test, right? So I think that's the beauty of testing in production. And next time somebody asks you, are you testing in production, I think you should not shy away in saying no, because it's impossible to not test out everything. And hence testing in production is a reality that I think all of us should embrace, right? Not everything is about shift left. Shift right is also equally important. And last but not the least, embrace the chaos. Don't try to over control, because things will never be fully in control. And the ability to cope up with this dynamism, the ability to embrace this chaos is something that's going to help us become better quality engineers in our teams. Thank you. Open for questions.
Wonderful. That was a fantastic talk, Vanya. I mean, I let you take a deep breath, have some water. I think
I'm
that
sorry
was
about my cough. It's post COVID. It's like this is remnant.
absolutely no. I think it was great. It's just like a release train, right? How we organize a release train. It was exactly like that. And I was doing some shameless plug as well in the chat. I'll let you, take a look at it that as well. I think the way you ended was pretty good. It's again a shameless plug again, because day after tomorrow I'm giving a talk on the titled "Balancing the Shift for Optimal Quality," where I talk about shift left and shift right. So whatever you told was absolutely fantastic, and I'm saying it publicly. I'm going to steal a couple of things from you, and I'll with proper credits as well. And yeah, I think it was definitely wonderful. We learned a lot of stuff, and the way you started off giving a situation for, I think people across different roles have joined the session, like being QAs to devs. As I'm also having some private chats where people DMing me and saying, "Will this talk be available in YouTube? Is it recorded?" and all of that. So from that to coding Cindy Sridharan, right? Any talk on observability, it's good that you quoted Cindy Sridharan, so it is always great. Thank you so much. We definitely have a couple of questions, but we also on top of the hour. Would you be okay to spend another 5 minutes,
Yeah,
Vanya?
should be okay. I would love to answer some of the questions. Yes, please.
Cool. Thank you so much. I think slides are available downloading later. I think it should be available as a complete recorded video, Elizabeth. It should be available. I think as you registered for the webinar, you'll get an email. Couple of anonymous questions. So let me pick randomly, or maybe you could. How do you verify that observability data is being analyzed effectively and that insights and recommendations generated from this data are accurate and actionable?
Yeah. See, at any point of time, as I said, right, it's not about plugging in a tool and getting that log out or getting that trace out and observability is done, right? I think the whole thing starts from what is the entire part of production? How as a team are we coming together to put in some thought on what is that data that I should capture? What is that optimum information that I should emit out of my application in the form of logs or traces or metrics, right? So if a team is, and in a large program, I'm sure you folks must be working in as part of large programs, there are multiple teams, and that's where the observability strategy or the guidelines become important, right? That how do you set up guidelines for different autonomous teams to follow such that that is being verified, right? So it's very hard to put these controls, to be honest, in place, but it's all about guidelines. How do you manifest some of these things as strategies for your teams to look up to, right? That's the way you can verify and effectively, say that my observability data is going to be actionable and it's going to be accurate, right? Just like you talk about the quality of the data, right? In order to create a good insight on top of my data, the quality of that data needs to be good. And as long as a team is sticking to the guidelines that are created and enlisted in your observability strategy, that should be the onus of the team to say that my observability data should be top notch. My observability data should be of high quality such that my DevOps engineers, my quality analysts are able to observe the system, right? And it's a feedback loop, right? So if something is wrong, you create that feedback and fix that signal or fix that data, and that's how it evolves, right? So it's a learning and iterative process is what I would say. Hope that answers the question, Manoj.
Yeah, definitely. I think can't agree more. I think took it wonderfully. So for a change, I'm going to ask a question that I have in my mind. I think a lot of QAs who has been listening to this talk. So not many of them have an opportunity to work in microservices environment yet. So asking questions on their behalf. As a QA who's not exposed to microservices yet, but still I'm interested in learning observability. What are some advice that you will give, like in terms of steps to learn about observability, or is there a playground that I can, learn about observability, implement it, and look at all this, beautiful insights that we might get out of testing in production?
Absolutely. I think as I was giving the example of 𝐕𝐢𝐝, it's a very popular distributed tracing tool, right? And a lot of these open source tools, they come along with a sample application, right? So you can spin it up in your own Docker container and play with, how the steps are, or how the information is getting collected, how the traces are getting collected, and how can you visualize that on a 𝐕𝐢𝐝 UI? How can you step through the services? And I think setting that up locally for your own, as your own playground, and looking at the way the traces are being created and how the spans are getting created across the services, and how that context is being passed, exploring that application, example application, and then making your own changes and modifying that would be a fantastic way to learn about. And I think if you learn one tool, you should be able to abstract out the first principles that we spoke about in this talk. And that should be a good, setup for you to understand observability as a whole, right? And there are lots of fantastic articles and talks out there, which can give you a lot of information too. But I would say that if you really want to do it with your own hands, check out some open source projects, some open source tooling that's out there, and practice and set up the sample applications and try that out yourself.
Cool. If you could just allow a couple of seconds, I'll just quickly add one aspect of it. I'm sure it'll be helpful for QAs. So for those of you who are into automated testing, I'm sure you would have learned about the tool called Selenium. And in Selenium 4 grid, we have implemented observability, exactly the technology stack that Vanya spoke about. It's based on OpenTelemetry APIs within the grid. We use 𝐕𝐢𝐝 as a way of visualizing the traces, so you can neatly see what sort of how the span looks like. So we have implemented both the server as well as client, so that with all the instrumentation that you have done in microservices, you look at all the traces. But in terms of if you're using Selenium and if you're using Selenium Grid to distribute your test across multiple browsers and devices, you also get observability metrics from them. So you could imagine, right? You also get observability metrics from the microservices as well as from the front end, which is on the client side. So if you combine both, I think that becomes a greater quality. That becomes the true saying, quality is everyone's responsibility within the team. So that said, I think that's it for the day. And thank you so much for everyone joining today. And Vanya, again, it's a pleasure having you. Tons of tech-oriented QA stuff. I'm sure a lot of people learned amazing stuff on observability and testing in production. Thank you for joining us again.
Thank you so much for having me on this session. Please feel free to reach out to me on LinkedIn or Twitter. I would love to respond and engage in conversation if there are any follow-up questions as well. Thank you so much. Bye. Have a great day.
Thank you, everyone. See you on the next edition.
Bye.